Now let's see how you can calculate a projection of one vector along another. So it says here that we have to calculate the projection of vector A along vector B, and we also have to calculate the projection of vector B along vector A. Now in layman terms, let's see what projection really is. Now the name really gives away itself, but this is what it is. Let's say that this here is vector A and this here is vector B. Now the projection of vector A along vector B would be this, the shadow that vector A casts along vector B. So this would be, let's just call it A prime, the projection. And a simple way to calculate this is to first take the dot product of A and B and divide it by the vector that the projection is being taken along. So in the first example, this one here, it says there that we have to find A along B. So you take the magnitude of vector B in the denominator, right? Because that is the vector that it is being taken along, right? So, and obviously in the second case, you would again take the same A dot B in the numerator, but you'll divide it by the magnitude of vector A because that's what the projection is being taken along. So, and you can see that if A makes a 90-degree angle with B, so this is B, right? This is A and this is B. Then you can see that it has no projection, and that can be proven because in this case A dot B would be equal to 0. This is a very beautiful example. Now it says here that A is equal to I minus K, so plus 1 on the x-axis and negative 1 on the z-axis, and B is J plus K, right? So A dot B, you first obviously have to find A dot B. Now that would just be 1 into 0 plus 0 into 1 plus negative 1 into 1, and that gives you negative 1. You found A dot B. Now in the first case where you have to find A along B, you need to find the magnitude of B, and in the second example when it's B along A, you have to find the magnitude of A. So let's just calculate the magnitude of both A and B. So the magnitude of A is simply 1 square plus 0 square plus negative 1 square, which will just become the under root 2, and the magnitude of B will also be under root 2. Now the projection of A along B is obviously equal to A dot B over the magnitude of B, which is equal to negative 1 over under root 2, right? Because A dot B was equal to negative 1 and the magnitude of B is negative 2, is under root 2. And similarly for B along A, it's the same, negative 1 divided by under root 2. So this is how you calculate projections, a very simple concept, and I hope that helped.